Hello, everyone. Thanks for tuning into this presentation. My name is Sander Valke. I'm the UI team tech lead at Bricsys. And today I will be talking to you about how we ported and are porting our desktop CAD application to Qt. As is usual during these kinds of presentations, you can type your questions in the chat box during the presentation, and I will be ready there answering them. A brief introduction is what we will start with. Then I will go into the architecture, following up with some core functionality that I will highlight, and wrapping up some pointers for using QML on the desktop. So who am I? Sander Valke. I took my first steps with Qt already, almost 15 years ago. Most of that were hobby projects. So at Bricsys is actually the first time I was able to work with Qt professionally. I've been with Bricsys for a bit over 5 years, currently working as the UI team tech lead. I manage the team, but I'm also still a developer, and I really like to use empty items as spacers. These are the very talented people that I work with. So in the development team itself, we have Mike, Razvan, Michiel, and Miguel. And then there is close cooperation, of course, with the UI UX team, Anne, Hannes, Rose, Selchin, and Santiago. The ratio of people in the two teams seem a bit odd, but the UI UX team does a lot more than just working with the UI dev team. So that's why there are 5 people there and only 4 in our team. And we are actually looking for more talented people. So what is BricsCAD? BricsCAD is a typical CAD application in the sense that from the basic layout. So in the center, you have your content that you're creating or that you're modeling. In this case, you have a 2D modeling of what looks like a big building with a lot of rooms in it. And then on the top, you have the ribbon. Optionally, there is also a toolbar there. You can see on the right, you can see a panel strip where you can add docked panels. And on the bottom, we have the command line, which is something that is often used in CAD and very often in BricsCAD. We can do mechanical assemblies. So here you can see a mechanical assembly being done in BricsCAD. We also have a module for point clouds, but the important thing here is that the configuration is always more or less the same. So there is something stacked on top of the application. You can have panels on the left, on the right. You can also detach them, and then typically there is a command line on the bottom if you want it. So BricsCAD is cross-platform. We run BricsCAD on Linux, Windows, and Mac. There are built-in modules for architecture, mechanical, for site modeling, for point clouds, and some more stuff. Our build system is CMake, and we are currently on C++17. We hope to switch to 20 this year or next year. We might be a bit held back by the C++20 supporting plan. We will have to see. We have an extensive third-party API. So the modules that I mentioned and showed are what is built into BricsCAD, but we have a huge API that people can use to build applications on top of BricsCAD. I think we're currently there are certainly more than 1,000 different third-party applications. So that's actually the right now the major value of BricsCAD is using it as a core to build a third party, or at least a big part of it. The UI, and I have to say was, because this is no longer the actual situation, but the UI was written uniquely in wxWidgets on Linux and Mac, and we also had some MFC sprinkled in on Windows. We have more than 100 developers all over the world, and the headquarters are located in Ghent in Belgium. So for Qt, some details before we get started. We're currently on 15.11. We want to migrate to version 6 before our next major release. So that means before October next year. and we don't use a custom Qt build. Might be interesting for people. So we use the pre-built libraries, and we would prefer to use those as long as we can. So yeah, the first question that you have to ask, or that people ask me, of course, is why move to Qt? And we basically made a list of pros and cons as one does in these situations. So a big pro is using QML for UI development. So we did have some QML experience in-house from people from working at previous companies or hobby projects. And there we saw, okay, the development speed that we had when creating UI. Before, we were really not happy with this. We had to sink a lot of time in creating the UI. And the second point that I mentioned there is pixel perfect reproduction of the designs. So not only did we have to invest a lot of time in creating the UI, at the end, what we delivered was often more like a caricature of what the UI team delivered, instead of being something that was really close to or a perfect reproduction of what the UI team delivered. So that left the design team was not happy because what we delivered was not what we asked, and we were not happy because we sank a lot of time in trying to get as close as possible, but we were just limited by the framework, by what it allowed us to do. So we both want to have better UI, better looking UI, better working UI, and we want to create it faster. So we want to have the cake and eat it at the same time. Qt also provides us a possible avenue towards WebAssembly. We've been playing with this a bit, and this work, the state of this in version 6.4 is actually pretty good. With some small internal tools, and this actually works pretty good. So we want to keep this. We want to keep this road open. It's also truly cross-platform in the sense that before we actually had a dedicated team of people, with at least 3 people working on Linux and Mac issues, basically full time. And that's because the bulk of our clients and also of our developers works on Windows. And when we created the UI on Windows, we had to go to Linux and Mac and test it, not to see if it works, but to see what exactly was broken, because it was, this was basically the standard. Writing a UI on one platform always meant having to go to the other platforms and ironing out some problems. And we didn't want to have to invest this time over and over again. And with Qt, what we see is that once you write the QML, it just works the same on the 3 platforms, and it looks the same on the 3 platforms. And when there are issues that pop up specific to a platform, there are issues in the integration layer that we have. So then the core team has to step in and fix something. But of course, the attack surface for this kind of issues in the integration layer or in all of the client code, I mean, in all of the UI code that our developers are writing, is a lot smaller. So we have to invest a lot less time for it in fixing cross-platform issues. The documentation, this cannot be stressed enough. The documentation is simply excellent. It's some of the best documentation for software that I've ever worked with. And we have commercial support, and the commercial support, the people there are very technically skilled. And if we ask a question that they cannot answer, then they immediately seem to find somebody internally at Qt that can answer it. So the quality of the answers and the speed is top notch. Why not move to Qt? A big one is setting up the cost of setting up this integration and maintaining it. So that's one reason. The cost of converting the existing UI, and I could say the amount of time that we need to convert all of the time is huge, but that doesn't really cover how much work this is. We have a bit more than 30 static panels in BricsCAD, over 250 dialogues, which is actually not that much, I think, for an application of this size. But that is quite a bit of UI, and it is filled with these small interactions. If you click there and then press that thing, then this thing happens. So we've already been converting UI, and we can see that this takes a lot of time. And probably the biggest source of the biggest time sink is the fact that previously our UI code didn't have proper model view separation. So the previous framework that we use doesn't really have this like as a prime citizen in the way of creating UI. So most of the UI that we have just has the business logic and the UI logic is intertwined. And now moving to Qt and QML, we have to disentangle this. And this is a big part of the work, but the resulting code is simply a lot better because we finally now have proper model view separation. But that's a big cost. And we also have 2 UI frameworks, so that's additional complexity. That's also something that we have to take into account. But okay, we looked at the pros and we looked at the cons, and we decided 2.5 years ago that we want to give this a shot. So we want to have a better looking UI. We want to have a UI that behaves better on the different platforms. We want to be able to play with WebAssembly when we want to. So we decided let's give this a try. Let's see if we can do this thing. So what are some of the core requirements if we want to move to Qt? And there is one huge requirement, and that is that we have to allow UI rewrite across several major releases. We have one major release per year in October. We have a minor release in March, and sprinkled between that we have maintenance releases. But even if we just look at the major releases, that would mean that we or rather it is impossible to rewrite everything, to do the integration and do the rewrite inside of 1 year. So that is completely impossible. We're looking at in the beginning, the team was also not as big as it is now. So depending on the size of the team, we're looking at 5 to 10 years, depending on also where we want to stop converting things. So we have to be able to rewrite the UI across major releases. That was already clear from the start. We also don't want to let the UI rewrite be stuck in a branch until it is completed. This is, for one thing, this is demotivating, because that means people would be converting existing UI now, knowing that it's 5 to 10 years before this actually is released. But not only that, the merging alone would probably, after 1 or 2 years, would make any progress impossible. So this is simply not possible. And I also think that shielding the new UI using defines or using ifs or whatever, that would also quickly become completely unmanageable. Another thing is that we actually want to immediately switch all UI development to QML. So what we did not want to do was even, let's say that we have a path where we say 3 years from now, or even 2 years from now, we're going to let this integration hit the main line, hit our main branch. That would mean that for the next 2 years, everybody writing UI code knows that this is something that will have to be converted, like immediately afterwards. So that's not something that's not motivating for the developers, but that's also a terrible business case, because what we're writing is immediately obsolete. So we want to be able to, like a couple of months after we do this integration, we want to be able to say from this day on, everything that is new in the UI has to be written in QML. So that's pretty powerful. Another constraint that we have that's really strict, but that's maybe has less of an impact on what we do, but that we really have to obey really strictly, is that we cannot break any third-party API. So not only don't we want to update any of our third-party APIs, but we also we cannot break any of them, because they are they are a big part of our livelihood, actually. So what do we conclude from this? And it's immediately clear that wxWidgets and Qt and MFC on Windows have to coexist. There is simply no other way around this. We have to have them simultaneously in BricsCAD. Some additional goals, and those additional goals are not something that we decided on from the onset, but that we did see, let's say, in the first 2 to 3 months after starting to set up the integration. And this is, we want to have a really powerful version of QML reload. We don't just want to have live reloading, like you write in your source file and then you immediately see the results reflected in whatever is rendering the QML. So we don't just want to have this in, for instance, in QML Live or in other tooling. We want to have this inside of BricsCAD. So we want to have the QML that's really inside of the application coupled to the rest of the backend, and we want to have we want to have live reload there. We also want to ship compiled QML. We don't want to ship source files. And we want to allow developers to use Qt controls too. This is a bit unrelated to the other topics. I will come back on that later. So how do we start this? And to start, let's take a look at BricsCAD. And again, you see, okay, we see the model, we see some panels, we see the command line. What we actually see here is we have our content area that we're going to ignore for the rest of the presentation. And we have 3 panels here. And this immediately got us thinking, because if we could show QML in individual panels and also show QML in individual dialogues, then we might actually have a way to make this work. So, okay, let's see if we can do this, because from when we started, we had no idea, is this even possible, what we're trying to do here? So what do we need? We need an application object. We cannot call exec on it because we have an event loop. It's been tweaked. On Windows, it's driven by MFC with wxWidgets mixed in. On Linux and Mac, it's driven by wxWidgets. We cannot touch this. We have so much third-party applications. They are some of them are really sensitive to the order that events come in. Some of them do custom things with event loops, so we cannot touch this. So we just have to sneak Qt in there. We saw that there is this thing called a QML engine. Makes sense to create one of these. And it also, we saw that there is this thing called a quick view that allows rendering QML. So then we thought, what about creating one QML engine and creating multiple quick views? That sounds like it's something that could make sense in our case. So, okay, then we did what you do in these situations. You hit Google or DuckDuckGo, and you look around, and then we found this Qt migrate project. It's pretty old. Some things in there are no longer relevant or no longer correct, but it actually gave us a good starting base to start with this integration on Windows. So what does this contain, this project? It contains a QWin widget, and this provides the bridge between Qt and MFC. And it also between a Qt widget and MFC, so actual Qt content. And there is also the QMFC app, and this is, we use it more as a convenience because we have a CWin app, and this makes it easy to create a Q application. There are hooks that are provided by the MFC app, but we don't actually use those. So a bit more detail. This is more detail, I think, than is interesting in this presentation, but it is interesting to see the order of embedding that we have here. So we have a quick view, and this quick view is embedded in a QWin widget, because a quick view is actually a Q window. So this thing wants to be a window, so it wants to be a separate thing on your desktop, but you can actually embed a window into something else. So we embed the window into our QWin widget, and so this QWin widget is the component from the WinMigrate project, and this provides the link to MFC. So now we already have QML linked to MFC. And then we embed this in an internal class, which provides the link to our panels. So this is called an MFC Qt window. And then this again is embedded in an internal class, which provides the link to wxWidgets. So this provides the link to our MDI system. So now we have something that starts from QML, embedded MFC, embedded basically, again, MFC embedded in the wxWidgets. And there we have the merging of the three frameworks. On Linux, the situation is comparable, but actually simpler because we don't have the MFC component. So there we just take the quick view, we embed it in an existing panel. We can create a wrapper around an existing panel using the from-win-ID function, and then we embed that into our MDI framework. So it's easier because there is no MFC. So that we set this up on Windows initially, and then we did some testing. We were pretty quickly arrived at being able to add QML into BricsCAD, which was even a bit of a surprise to us that this was even possible and worked this well from the outset, from the onset. So we didn't have to tweak that much. So we saw that this works on Windows and then also on Linux and Mac. This works. We see that a quick view consumes like up to 30 megabytes under normal circumstances. The thing is that we don't expect 100 views to be open in BricsCAD. We expect like typically around 5. So you have the ribbon, you have a panel docked on the left, you have a panel docked on the right, you have the command line. Maybe there is a panel that is detached. People open a dialog, maybe there is a sub-dialog. So it can go up to 10, let's say, but that would already be more or less a maximum of quick views or panels and dialogues that you can reasonably expect to be open at the same time. So that means that typically we're going to be introducing 150 megabytes of extra memory consumption. And this is a price that we had to decide, do we want to pay this or not? And we thought this is okay. Okay, on modern computers, I mean, we don't want to be the guys that say, yeah, our application consumes 2 gigabytes of RAM on startup, and this should be fine. But that's also not the case. BricsCAD was pretty lean, so 150 megabytes extra is actually significant in terms of what we were already using. I think around 200 to 300 just on startup. But it's still like the overall memory consumption of BricsCAD is still very much acceptable. So we thought, okay, we're willing to take on this extra burden. And this is something that we will have to see, and hopefully we'll see this year. There have been reports about and works towards reduced memory consumption of Qt in Qt 6. So we will see, and then there's also the possible further reduced memory consumption after compiling QML. But all of that is for the future. So this is where we are now. And then yeah, deploying, because that's also something that's really important, but that you don't see that often. How do people do this? So on Windows, we use WinDeploy-Qt. So this actually works quite well. You have to figure out the command line to use. It's not that easy. So you have to point it to the binary. You have to tell it where is like the root of my QML folders. And then it does its thing, and it just copies all of the dependencies, and then we can just add all of that to our normal framework that creates our installer. So that works well. On Mac, we have the same. There is Mac deploy Qt. So yeah, it works well. No issues there. On Linux, it's a bit difficult. Not difficult, different, and a bit difficult maybe. Because on Linux there is no Linux deploy Qt. But I think there is a Linux deploy Qt, but it's an open source project and it doesn't really do what we want. So yeah, I think on Linux, applications are typically expected to use the system binaries, but we don't want to use that. We want to use the specific Qt version that we tested with and that we have internally. So what we do there is we just wrote a script that we look at what is being copied on Windows and Mac, and we copy the same stuff in a custom script. And then from time to time, we have to update it. But actually, like once we got through the initial integration, what is being copied doesn't really change anymore. So once we had the script, we were basically fine. And that means that on Linux as well, what we deliver to clients is still self-contained. So we don't rely on system binaries, or at least not on the Qt system binaries. Developing, so some rules that we, or pointers that we developed during the past 2 years of working with Qt at the scale that we are, because the scale is not that small. One really strict rule that we set up from the beginning, and that was because I was really, I was personally worried about, because we're working with QML. QML is scripted, even with setting up sufficient testing. I mean, what is sufficient testing? But I was really worried about the fact that QML isn't compiled. So I didn't want to run into making changes in QML and then stuff breaking in the software all over the place. So we just made some rules from the start that try to minimize this as much as possible. And one rule that we're really strict about is that client code. And with client code, I don't mean our clients. I mean the clients, the UI dev team clients, which is all the other developers at BricsCAD. So their code, their C++ code, is never allowed to directly go to the QML and do something. So they're not allowed to take a Q object from the QML and then access or modify the properties. Not only are they not allowed to not modify it, but they are not allowed to access them, and certainly not call slots on them. So we do make an exception for framework code. So that's the code that we write, because sometimes to do the integration, we just need to go to the QML and we need to do something. We need to do some stuff on the QML, for instance, to be able to have automatic resizing of our QML content when we're for our dialogues and for our panels. So we do make an exception there. But we've had this as a rule for more than 2 years, and this is working out great. So that's good. The way it works is that every panel and every dialog is powered by a dedicated controller. And a controller sounds more complicated than it is. A controller is basically a class that inherits Q object. So when you create a panel or when you create a dialog, you create a controller, and all of the communication from C++ to the QML happens through this controller object. So what happens is, basically, when you create a new dialog, for instance, you ask our framework, please create a dialog. You tell it, this is the QML file that should go on the dialog initially. This is my controller that goes along. And then the framework uses set initial properties to set the controller as an initial property on this QML file. So this is really powerful, also because we don't use context properties anywhere. So we always set initial properties, which allows the controller to be a required property on the dialog and on the panel. So that's really cool, and that also means that there is no at no point do we use this magical properties that are present in the context, but that you cannot really see or touch, and that you just have to know about. So this is the way that we work, and this has been working out really well. It's actually. Maybe a bit surprising, even because when we started, we just thought, let's try to do stuff that makes sense. But we had no experience at this scale, because at any point we will have 10 to 15 people at the company writing QML code. So it's not only inside of our team. We try to think ahead, but that's really difficult. But this has been working out really well for us. BricsCAD again with the UI how it was before, and then BricsCAD with the UI how it is now. So these, I picked the ribbon and I picked the layers panel here because those are two components that have been converted. This conversion is an ongoing process, of course. So that's really cool, and I do want to highlight something in the ribbon here. So the way the ribbon looks now is actually quite close to the way the ribbon looks before, and that's because we had invested a lot of time in fine-tuning the UI of the previous ribbon that we had. But now that we have a new one, we thought it would actually be nice if we had a search in the ribbon, and this is something that we wouldn't have started on in the old one because it would have been so difficult to get this to work. But in the new ribbon, this was this kind of stuff, you basically get it for free. So we added this search. It's maybe an exaggeration to say it was added in half a day, but it was not a lot more than that. And now we have a super powerful search functionality in our new ribbon. So that's really the power of QML. And we, also internally at Bricsys, we still have to get used to that. We're a lot of the time we're no longer limited by our framework, but the limit is really our imagination and what can we do with our UI now. Okay, so that's basically the core requirement satisfied. So the wxWidgets and Qt and NFC on Windows are coexisting in BricsCAD. So we managed to get this to work. Moving on to live reload. So what is live reload? We want to be able to have a developer modifying QML, any QML, really any of the QML that we write. And this has to be able to be, the UI has to be refreshed live inside of BricsCAD. Because it's pretty easy to have live reload outside of BricsCAD. We typically use QML live to do this, but then you don't have the interaction with all of the other components in the software. So we do want to move, like typically keep the QML development as long as possible on QML live, but at some point you move to inside of BricsCAD and you don't want to lose the live reload then. Sorry. We also want live reload for developers as well as designers. And our designers don't have a C++ development environment. And we also like our designers and we would like to keep them working for us. So we also don't want to ask them to install a C++ development environment. So that's another thing to keep in mind. We also don't want to ship our QML to clients. We do want to hide this a bit, so we want to compile it. And actually, I didn't know about Qt6 QML compilation at the time, but this will tie in really neatly with that because we are actually free to really compile our QML and it won't change anything for us internally or for our clients. So how do we do this? And the way we implemented this is that we have variables inside of BricsCAD. You can set these using the settings dialog or using the command line. So we added a new GUI development variable, and you set this to the root of the Git repository that you have to have checked out locally. And what actually happens under the hood is that when the QML engine imports plugins, it's going to look at the plugin paths that it knows about. And this is a fixed order, so it's going to look at the paths one by one, and when it matches a finding plugin, it's going to use that one and stop the search. So basically what we do is when GUI development is set, we can insert the plugin paths for the source folder, so where the actual QML files are located, we can insert those before the paths where we have the compiled plugins. So this means that the engine will pick up the source plugins. So yeah, what does this mean? So we have components library in BricsCAD that has a lot of the standard components that we develop. And when GUI development is set, this plugin will be imported from the BricsCAD components folder in the checkout of the sources, so under the source folder. If GUI development is not set, then the import will happen from the binary directly. And so this is only for internal builds. So this functionality is not present in builds that we ship, of course. And how are these two related? So how is the plugin in the source folder related to the plugin in the binary folder? We compile the plugin. This is part of our normal build process. So when you compile the application, all of the plugins that where the sources have changed are compiled as well. So compiling the plugin, what does this mean? It means compiling the plugin in the Qt 5.15 sense of the word. So there's the Qt precompiler at resources. We add any assets and other files that need to go into the library. And then, this is a bit peculiar maybe, we transform our QML files. And yeah, why do we do this? Because actually the QML file that you want to use with a plugin where all of the QML files are present on disk, or a QML file where the QML is present in a library, those have a slightly different format, and we don't want to have two QML files in the sources, because that will quickly be a disaster where people forget to add things to one or the other QML file. So yeah, what does this mean actually? So a source folder QML file looks like this. So it lists all of the components that are part of the public API for this plugin. And the QML file for the compiled plugin looks a bit different. So you can see that it lists the same list of components, but all of the component paths have a QRC inserted in between. And this means that when importing the plugin, those components will actually be looked for in the compiled plugin. So that's needed. And what's also needed at the bottom of this plugin is this plugin and then the name of the plugin statement. So yeah, this transformation happens with some string manipulation, and this also, yeah, so this works. So this is, for instance, the contents of the BricsCAD components plugin. So you can see all of the QML files, some CPP file and H file that contain the actual plugin definitions. And then this is what the compiled plugin contains. So there's only the SO on Linux, and there's the QML file that was changed in the way that I mentioned before. And this is it. So that's really clean. So what we ship to clients is really clean. Internally, we also have the plugins.qml types files in the bin folders, but yeah, and those are not being shipped right now as well. So the setup allows anyone at Bricsys to get a copy of the sources, set GUI development, and have live reload. And there is no C++ environment needed. There is one restriction, and that is that you cannot have QML and C++ in the same plugin. Because to use the C++ code in a plugin, you need a compiled plugin, of course. But then if you're using the compiled plugin, that means that you're no longer reading the QML from the sources. So what we do is, and this is really more of an organizational thing than something, we haven't seen anything that this doesn't allow us to do. We just split our code in QML only plugins and C++ only plugins. And there is actually not really something that this does not allow us to do. So it's just something that we have to keep in mind. So this is the live reload in action. So what you see on the right is really the source file powering our layers panel. So we have a table view BC component, which is a wrapper around table view. And you can see that I'm changing the row height here live. So we don't actually reload on save. I think that would get in the way really often. And every time where you save, where you have accidentally typed invalid QML, it means that the panel becomes empty. We do have ways to recover from that. But I think that would be annoying. So we just added a button that's only visible when GUI development is set, where you can manually reload the panel. And this has been working really well for us. So we're super happy with this. Okay, and then the last part I want to get into is the Qt Quick Controls tool, because yeah, when you're writing a desktop application like this, you have a lot of components where you want to use a custom style. You have labels, scroll bars, and whatnot. And the question is, how are we going to offer this set of components to our developers inside? And there's basically two ways you can do this. You can have a style plugin, and this is a customized set of Qt Quick Controls 2 components, where these components are automatically used by the Qt Controls tool. Or you could create a custom set of components, label BC, button BC, BC for BricsCAD. So this is what the two approaches look like. The style plugin means you just import Qt Quick Controls and you use a label. The custom components mean you import BricsCAD components and then you create a label BC. So the Qt Quick Controls tool is very well documented. So that's a big bonus. The API is really stable, is discoverable. And you don't need to guard against people accidentally using Qt quick controls because people are supposed to use them. The custom components, the API is easy to expand, which is good, but you need to remember to use these components. And you need to be very sure that when you are changing the API, that you don't break any code. So seeing the pros and the cons here, we decided to go with the style plugin approach because of the API stability and because of the reduction of risks that comes along with that. So from our internal wiki, we do have a strict rule where you cannot add properties or functions to style components. So we have the API provided by the Q controls is very good. There's a lot of things in there, so just stick with that. And this works quite well in practice. So yeah, to start with, you copy an existing controls to style, compile, and customize the components. So these are all the components that we have. And then, yeah, some details. So on startup, you import the plugin because the components are inside of the plugin, and then you actually set the style. And that means that from that point on, the Qt controls will be using this style. And this is an example. So you can see some components here, text field, text area, that are actually, so these are Qt quick controls that have been styled by us. All right, and then to wrap up, and this is something I could have multiple sessions of a day about QML for the desktop, but I'm very briefly going to skim over some lessons that we learned here. So delegate chooser or loader, two components that allow dynamically creating QML. Which one should we be using? The thing is, and I'm going to show an example here, delegate chooser allows using the roles that you expose in your models directly without any further difficulties. So you can see label code button type, we're using those in the QML on the right. And this is a lot more difficult with a loader. So the thing is, if you can use a delegate chooser in your list views, in your table views, in your tree views, it makes a lot of sense to use them because they just work so well. So table view and tree view in particular, we need delegate pooling. That's something that we learned. So delegate pooling is a reusing of delegates instead of recreating the delegates. So this is something that's on by default. You can switch it off. We learned that we need it. Delegates are also pooled and reused when rows are added and removed. So this also means, for instance, in a tree view, collapsing or expanding a node. And delegates can move around in the view when they are being pooled. So this does means that you have to take care if you're for instance rotating something like a tree indicator. This can mean that the tree indicator moves to a different row. So suddenly the tree indicator of the wrong row is rotating. So you have to pay attention to this. So a good guideline is to only modify delegate properties that are bound to a model property. So this is a really general rule, but for instance, for the rotation, if you want to rotate the tree indicator, you have to store the rotation value in the model. Yeah, so something else that we learned, and I just want to highlight that this thing exists. So it's really easy to break bindings in QML, and there are ways to be notified about that. But for instance, setting some value in JavaScript or selecting an item in the pop-up for a combo box also breaks a binding in this case. So you can persist bindings by using the binding component, and this is part of standard QML. So this is something that we discovered a bit later in our journey, but is really powerful. So it's something that you will be using all over the place, actually. And then the last thing that I want to say is, yeah, row layout, column layout are really important for desktop development because they allow dynamic sizing. So they allow components to say, I want to be this big, this bubbles up to the top, and then we can say, okay, but the dialog is only this big. And then, so what bubbles up are implicit sizes, and then the real sizes are communicated down. So what this allows us, and this is a preview of this, what becomes basically free when you use row layouts and column layouts and other layouts is dynamic sizing of your UI. And this is, of course, really important on the desktop. For dialogues, but also for panels, for instance. Okay, so this is all that I wanted to say. Thank you for listening. It has been a really interesting journey for us so far, and it continues to be an interesting journey and will be for the next years. Everything has been working out really well for us, and I was happy to share this part of our journey with you today. So again, thank you for listening.